Hello, my name is Annie Wu,
Hi, my name is Anna Cybulski.
and this is our research on testing the degradation of biodegradable plastics. So the purpose of our project is to identify which soil microbes are involved with the degradation of our biodegradable plastics. We want to determine the changes in the plastic over time in soil, and previous research has shown that microbes in the soil are shown to have plastic degrading abilities. So for our materials and methods, we have 3 different types of plastics that are used. They are all biodegradable polylactic acid plastics, which are PLA for short. So if you look at figure 1, these are the 3 pictures of our 3 different types of plastics. The very first picture is sample 2, the middle picture is sample 1, and the third picture is sample 3. So this is how our plastics look before they are tested in the soil. And the 4 types of soils that we use to test our plastics in are Timberline, cow manure and compost, Miracle-Gro potting mix, Miracle-Gro performance organics, and farm dirt. So our samples are potted and left in the soils for 1 to 6 months. After this, we collect our samples. They are cleaned and scraped for microbial biofilms. The microbial biofilms that are scraped are frozen in pellets and sent for identification using DNA sequencing. We also record changes to our plastic appearances and their thicknesses. We use infrared spectroscopy to identify chemical changes in the plastic.
After pulling plastic from the soil, notable changes can be seen, which is the equivalence to degradation happening within the soil. Our plastics are duller and thinner than when they were placed. Some plastics also show signs of curling, cracking, and texture changes.
So if you see on the bottom from figure 3 here, this is our sample 3 left in farm dirt that was collected on October of 2021. You can see on the top corner of the plastic that there's some dullness that wasn't there before. Figure 4 is a Timberline sample 3 collected in October of 2021. You can see this plastic is completely dull. It looks nothing like how it did before it was placed in the soil. Figure 5 is a sample 3 from farm dirt that was collected in February of this year. You can see from the edges that it's starting to curl. There are some texture changes. There are some cracks in the center as well. And figure 6 is a farm dirt sample 3 that was collected on January of this year. And you can see that the sample 3 has a completely different color to it. It's no longer clear. So this is a sign of our physical degradation.
The following table is a table representing the thickness of the plastic samples taken from the soil in January 7th of this year. The first section of the table shows the samples from Miracle-Gro potting mix. The second section of the table shows the sample measurements from the farm dirt. The third section of the table shows the measurements from the Timberline soil. The fourth section of the table shows the Miracle-Gro premium organics sample measurements. Plastics from 2 of the 4 soils tested show noticeable changes via IR spectroscopy. The 2 soils are the Timberline cow manure and farm dirt compost. Results come in the form of hydrolysis taking place on the plastic samples. The yellow circles on each diagram represent where you will see changes that are noticeable between each diagram. The diagram on the left is the plastic control sample. So this plastic has had nothing done to it and is completely straight out of the box, while the sample on the right is the plastic treated in the farm dirt soil. And as you can see, the top circle shows a large dip compared to the control sample, while the bottom circle shows a shorter sword length compared to the one on the left side, which shows the hydrolysis taking place.
And for our future research, we plan to test our plastic samples in our university garden beds where there are plants. We would like to find out if the microbes from plant roots will have any significant effect on our plastics. Thank you.